Thank you, Andrew. Thank you for being here, the hardcore people that are here at the last session. I really appreciate that. It's been a great conference, I hear, right? Good, good. What I want to talk to you about today is software development processes and security. So we're going to kind of walk down a little bit of history as far as process models. Some people call them methodologies and such. A little software security humor I thought would be a good way to start. And a lot of times we, as developers, as programmers, we tend to think of security many times as somebody else's problem, or somebody else is going to look for problems and errors and so on. And for many years, that was the case, right? We were the developers, and then we passed it off to quality assurance or other people that were doing testing, and then they'd give us a lot of information back. But many times it was in a format that we really didn't know what to do with it. So let's talk a bit about the phases in the systems development life cycle. So these can be thought of as phases, as things that we do, and some people talk about the communication, planning, modeling, construction, and deployment. You might have heard it referred to as initialization, modeling, designing, implementation. But basically, these are the core phases in any systems development life cycle, whether we're using a more traditional and older process model like Waterfall, or something much newer and much more flexible, as we'll hear about with the Agile processes. So we think of first, when we're talking about the methodologies or the process models in software development, as the flow, the process flow. And there's the linear flow, which is very sequential, and basically the 5 framework activities that we saw on the previous screen would begin the communication, and once we finish that, we would then go to the next phase, planning. And there was no revisiting of the previous phases. At the time, in the 50s and 60s and even 70s, that was seen as, hey, it's better than what we had before, which was really nothing structured or nothing really set in place. So it had advantages, and still today, for some software projects, it still may apply and might be a good technique. However, as technology has changed, as customers and users' requirements have changed, certainly the process models have changed with it. So the next kind of type of process flow that came about after linear, and we'll see how that equates to Waterfall, is the iterative process, where the activities are repeated, right, and could be done many times, but it would actually be repeated before the next iteration would occur, and typically that meant we had some product, some software at the end of each iteration. And then there's a variety of evolutionary process flows, and that tends to take the best of the iterative approach, some of the structure from the more linear and iterative processes. So let's just look at how this we might see this using the 5 frameworks. Of course, as linear, and we'll see in a moment how that equates to Waterfall. Then we've got the iterative process flow and some evolutionary process flows where we're feeding back information, reviewing things that we've talked about in the planning stage, maybe adding new functionality. So the Waterfall is considered kind of the traditional, oldest, classic life cycle. And back in the 50s, like most of our software development techniques or concepts start first by people writing about it and talking about it, and then it gets some popularity, and maybe people are thinking about it. And then as time evolves, it comes to fruition. Something is actually documented and used in this case, software development. But you can also think of when you're referring to databases, how the relational database model by E.F. Codd, that was written about and discussed many, many years before the relational database model ever came to fruition. So as I said before, the Waterfall is very structured, systematic, linear, And basically, we go through the phase, and once we end one of the phases, like communication, we go to the planning. And then once we've finished with the planning, we go to the modeling and so on, and we never have a chance to revisit. So as we sit here today, we can see that there's definitely some problems there, right? Possibly new requirements, new things that have changed, maybe new laws or new policies that we would have to reconsider some of the things that we've talked about earlier in the phases. So definitely some disadvantages of the waterfall. But we're not going to throw the waterfall completely out the window because we still see parts of it used in the later process models. So as waterfall, as the opponents of waterfall started looking at the waterfall and saying, wow, you know, really it's rare that we ever have projects that follow a purely sequential flow. And many times customers not only don't know what they need in the beginning, but sometimes those things change, and that could be because of their wants and needs, but it could be based on laws or other policies, as I referred to earlier. Okay. So, and with the waterfall, we don't really get an end product. We don't get a working product till the very end, till we deploy, right? So that can be problematic. Now, the incremental model, that kind of came after waterfall, and that, as you can see, the diagram shows that we go through these framework activities in various increments. And at the end of each increment, we actually have delivery of working software. And then we would have any number of increments that, depending on how large the software project is, and we would have something delivered at the end of each increment. And therefore, we would learn from what we've done. We'd learn about new requirements. We'd learn about additional things that we might have to add, features and such. And we can see that you know, it's a much better approach for most, not all, but most software projects to have this incremental approach. Okay, and it takes from the linear sequences, the waterfall approach, the linear approaches, and builds onto that in increments. So we don't have to wait till the last phase to get the software, and we can build in these various increments. Now, some of the evolutionary models that came about, and you might not think of prototyping as an actual process model, but in its early days, that's what it was used for, right? We would quickly put something together, design it, and we would get feedback from our users, from our stakeholders, and then we would build more or add more functionality to it. Today's world, though, we see prototyping used more as a tool to complement any process model, whether we're using waterfall or a slightly revised version of waterfall, whether we're using incremental or iterative or agile or any number of different process models. Prototyping is used as a tool to get feedback when users don't necessarily know what their requirements, they don't have them clearly spelled out. So we have to be careful, though, with prototyping, because many times our customers want to take that and say, oh, this is the end product, oh, great. But most of the time, that's not. We're just quickly putting something together to get their feedback, to get their input. So that was actually considered a model, a process model. And we need, though, to think of it really as a complementary tool for any process model that we might use. Another one of the biggies that you'll hear about, read about, will be taught about in any software development class is the spiral method, right? The spiral process model. And a guy by the name of Barry Boehm came up with this idea, and notice that we still have our 5 basic activities, our 5 framework activities, but we're doing it in iterations. It's a circular manner, and probably the biggest benefit or the addition to the spiral model is risk analysis is also considered now. In the earlier stages, that wasn't part of the actual iterations or increments, so that was a big plus with the risk analysis. This happened back in the 80s. Barry Boehm, who was quite well known and still today in the software development arena. It combines the iterative approach with prototyping and some of the very systematic aspects of the waterfall model. So you can see, like most things in life, right, we kind of, the new and improved takes what worked in the older models, what worked in the older processes, and then added to it. And we see many of our projects being built in this variation of a spiral model, right? Having a series of evolutionary releases, okay? It definitely does, a biggie is the risk management component in the spiral method. Now, the next kind of shift, or after kind of the iterative and the incremental, it was seen that Agile development, and my colleague here in the audience, he's written books about it, so I have to make sure I say it correctly here. But the Agile development, it was seen as something pretty different. I wouldn't say completely different, but real different. I mean, developing software, but in a very different fashion. And a group of about 17 software engineers and people in the industry met together at a ski resort in Utah and in 2001, and they came up with this Agile Manifesto. And the main deal with the Agile Manifesto and the Agile development, it was seen that software wasn't being built quick enough. It wasn't meeting users' needs necessarily. It was very heavy-ridden with documentation, and change was almost seen as torture or something that was looked down upon in the development team. So the Agile Manifesto had a variety of principles and philosophy behind it. And one of the kind of famous quotes from this manifesto is the following: the individuals and interactions over processes and tools, because these are considered kind of the older process models. We're more interested in processes and tools. Definitely more documentation, although I'm here to say we don't want to totally forgo documentation, but certainly more interested in getting an end product, an end result in a quicker way, and having something to look at, a working copy. And then customer collaboration over contract negotiation. In the earlier process models, customers were seen as very important because they usually paid the bills and they had some requirements they wanted us to build the system on, but there wasn't a lot of involvement in the development process with customers. And that's something rather new, and the amount of customer collaboration that Agile uses is definitely something much greater than in the earlier one. And then responding to change, seeing it as an opportunity to meet the needs of our users, to meet the need of our customer. Okay. So it's not that they disregard the items on the right, but the left items are they're focusing on that a bit more in the Agile processes or Agile development. So I think we know agility, what agility is, right? We think of Gumby or anything that can move rather quickly and easily. And when we refer to it in software development arena, it's basically effective, rapid, and adaptive responses to change, right? We have and strive for communication among all the stakeholders, and of course that means not just the designers, but the customers, the product owner, and a variety of other folks. So that's something that's stressed. Drawing the customer into the team or onto the team, and this might be one or could be a series of customers from key departments, and then organizing a team so that it is in control of the work performed. So we'll talk about in a moment how Agile development, how there's many different approaches to that, methodologies or approaches to that, but like all new processes or fairly new processes, we want to first see how agility, using Agile development, can cost us a lot less than other processes. And the diagram shows us that a well-designed Agile process, so there's not just one, there's many different flavors of Agile development, flattens the cost of the change curve. So we all know the earlier that we detect an error or detect that we need to change something, the cheaper it's going to be. That's kind of a given. And you can see that from the earlier process models, that was a bit challenging to do in Waterfall and some of the earlier ones, because it was very much from one phase to the next. Agile, though, kind of breaks those rules, and we'll see in a moment how it lays out. Okay, very much driven by the customer, and we think of the customer descriptions are seen as scenarios. Now, how many people in the room have developed using the Agile process? Okay, so many of you, it's one of the most popular, we'll talk about Scrum, it's one of the most popular Agile approaches being used in software development today. It seems a bit of chaos in a way when we first look at the components and the roles that people play, but it can be quite effective if done correctly. Okay. Develops software iteratively with a heavy emphasis on construction activities. We'll see in a moment that we have these short iterations of work being done called sprints. At the end of each sprint, we're expected to have and show a working product, right? And it certainly adapts better to change than some of the earlier ones. Now, back to the Agile Manifesto, they had a variety of principles, and I'm not going to go over each one, but you can kind of see how that emphasizes or re-emphasizes the philosophy as far as really wanting to satisfy the customer through early and continuous delivery of software, the collaboration of business people, the people that we're dealing with, we're building software for, as well as designers, having those face-to-face interactions. Also the concept of having the many meetings, and I'm not talking about the 2-hour kind that everybody starts texting. I'm talking about very short, quick, 15-minute stand-up meetings every day to find out what activities have been done, what problems may have come up, and then what needs to be, what will be done in the next day or two to fulfill the user stories in our sprint that we're looking at. So it's, goes along with the principles. I'm going to kind of skip over that. There's many approaches to Agile development, ones that have been used and have been quite successful, and you might have heard some of these, that Kanban, extreme programming, a dynamic systems development method, lean startups, and then Scrum. And Scrum is, as I said earlier, the most popular Agile methodology used, as far as many reports such as the Scrum Alliance organization definitely tells us that, as well as other software development organizations that survey and write on development by many organizations, government, as well as commercial, and so on. So what is Scrum? How many, do we have any rugby players in here? Okay, any rugby players? Okay, well, the word Scrum comes from the game of rugby, and it allows us to get together, interlocked with our team members, and march up the field to do various things in rugby. And I won't give you a rugby lesson because I don't know too much more than that about rugby, but I thought it was interesting, little tidbit that's where the name came from, Scrum. So it's not an acronym, it doesn't stand for S something, C, and so on. It comes from the game of rugby. So what is Scrum? Okay, we have these short work cadences, as I said earlier, that are called sprints. Typically, they're 2 weeks, anywhere from 1 week to 6 weeks, but the most common sprint duration, it appears, by various studies that have been looked at, is 2 weeks long. And the product is kept, the end product is kept potentially in shippable condition at all times. So at the end of each sprint, we have a working copy of our software. Okay. Now, one of the many diagrams that might show you or give you some insight into Scrum, and it's a kind of a busy figure here, but what's going on is we have the product backlog items. Now, as I said earlier, with the use of Agile, specifically Scrum, Our user requirements, our features and such, go in the form of stories or items. And that is put on what we call the product backlog. And that is what the groups work off to develop, to decide what features they're going to work on and who's going to be tasked with which item, and then what they're wanting to accomplish at the end of that sprint. Okay? So we've got our product backlog, which is a definite list of items or features that are going to be worked on, that are going to be included in the software. Then we have, of course, the development team. And the big thing with Agile development is self-organizing teams, meaning that the team decides what features they're going to work on from the product backlog, who's going to work on them. Typically, we have people that are skilled and that have strengths in certain areas and others and so on. So somebody might be a great programmer, other people might have their strengths in web development and deploying to the web, and a variety of other skills. So on the development team, it's not just the programmers, but it's the others that help in these the development activities. Okay, there's many times a customer that's part of the development team, or is at least a person that they can collaborate with and contact with and ask questions. There's typically what we call a Scrum Master, and the Scrum Master, he or she, kind of is the product manager of sorts, and they look at the activities that have been spelled out in the product backlog and kind of organize the team in a way, but it's self-organizing, but he or she is the one that's looking over the actual Scrum, the development of the product. Then we have the sprint backlog. So remember I said the product backlog, that's all the features that are going to be worked on, all the features that are needed in the software. And then we break them up into these 2-week increments, right? These 2-week sprints. But we have to have a backlog of what's going to be accomplished in the actual sprint that we're looking at. So a typical project might have anywhere from 5 to 20 sprints, depending on the size of the product. But those are divvied out as far as what features we're working on in sprint 1, what features we're going to work on in sprint 2, and so on. So you can see where this is pulling definitely from the iterative and incremental development and delivery. At the end of each sprint, we're actually having an end product software that we can look at, can demonstrate to our product owner, to our customers, getting feedback. But it also allows us to look back or look at, review our sprint to see, okay, what worked, what problems did we encounter, how can we correct those or work with those for the next sprint. Maybe we do have to put off a task or two. Maybe we did not estimate the amount of time correctly that it would take, right? That's part of the sprint planning process, and that's where we have the project management skills and the development team chiming in on those things. But we do have ways that we review the sprint, and we do sprint retrospective, so we can look back to see what worked, what didn't. So the different roles that play out in Scrum, and I alluded to them just in the previous screen as far as product owner or project manager. And he or she is responsible for the product requirements and priorities, right? So that's the person that's going to look at the features and prioritize them, right? So in the product backlog, we have a list of all the features, and then there's some prioritization as far as what's more important or what's considered more important, how long it's going to take. So that takes quite a bit of time to just estimate the priority level as well as the time that it will take to perform those different tasks. Then, of course, we have the development team. That's the team that builds the code and all the different nuances in that. We have the Scrum Master, right? So the Scrum Master, he or she's in charge of the stand-up meetings, as well as they work closely with the product owner and project manager. But this face-to-face communication, really meeting each day, standing up for max 15 minutes, talking about what you've done, what problems you might have encountered is very helpful. It's real easy as developers, as programmers, to kind of hide behind our computer and just maybe chat or send off an email or do something that is not eye to eye, face to face. Now that doesn't mean that we don't have remote people working on our team. Certainly we could use a variety of remote tools to help us with that. But that's one of the components or main factors in Agile is that collaboration and that accountability. Okay. So how do we can see, and in the earlier process models, we could see how security could be divvied out in maybe a phase, maybe in certain parts of each phase. But looking at this, it looks rather chaotic, and we're like, how in the heck are we going to ensure that we're writing secure code? How do we infuse security in Agile development or Scrum when we have these short sprints and we're working on the features and getting an end product? So there's issues that have to be overcome, especially for developers, designers that are not used to this approach, right? Anytime there's a new process or a new approach to something, we have to get people used to the new approach and how it's done. So some of the issues that have to be overcome, our traditional test may not fit the Agile process, right? So thinking back into Waterfall and some of the earlier process models, we might build in a month, 2 months, 3 months worth of testing. And that's just not going to work in using Agile, right? And we'll talk about some tools and some ways that we can do that in a little bit. Also, security data that doesn't necessarily integrate with development systems. In other words, we might have to have a complete finished product with the integration worked for some of the traditional tests that we're used to. Okay. So that's something that we need to realize, and there's many tools out there, new tools and things that we can build in and use in this shorter iteration using sprints. Also, just insufficient knowledge, right? As developers, we may not, this doesn't mean everybody, but some people are more into coding efficiently, coding effectively, really the ins and outs, but may not be that familiar with some of the security issues that we're faced with today. So that's where we get into working closely with people that are experts in security. This could be people on our team, certainly. Maybe some of our developers are very sufficient, but it might be if we were working from a traditional approach like the Waterfall or Spiral and such, we might have had those folks doing the testing, doing other things, doing the quality assurance, and we would want those folks, those experts, to be working closely with our team, okay, to educate, to update us on various security attacks or possibilities. Also, getting security into the work queue, right? So once again, in the earlier approaches, we had these phases and they were pretty much prescribed, but now, getting them in these sprints and making sure that we actually use them or have them as part of the user stories, as part of the product backlog list. That's real important to do, because if left unfocused, it might be pushed off into another sprint or something. So we don't want that to happen, right? Obviously, the documentation, we're not going to have the amount of documentation that we did in the earlier phases, right? So that's something that just would slow the process down, but that, once again, doesn't mean that we're not going to document anything, but we pick and choose the areas that we document for maintenance and for future sprints, but we wouldn't have the unwieldy large documents like we did with earlier process models. Okay. And some of the challenges, as I've said before, and this slide alludes to it, it's not a real structured sequential approach. It's things aren't broken up in nice, neat phases as they were in other earlier process models. So that could be challenging, just getting used to how we infuse it using agile processes. Uh-huh.
When you do the early planning for the agile process and you have various, I don't know the right term, but increments or builds, at the end of each sprint, you put in a sprint for testing or, some kind of security checks or code reviews or something to ensure that, the that you're following good security practices or whatever. And I can see that being, fitting in well with the process, but then going back and adapting the changes necessary to build security back into it if one of the team members didn't do it, correctly according to your, coding guidelines. Is that a way to address it? And if it is, going back and redoing some portion of it, how do you get that caught up with the rest of the team?
Yeah, interesting. Good question there. Actually, that would go back in the product backlog as far as something that needed to be worked on. So we wouldn't want to get too far behind. And that's in a few slides from now, we'll talk about things that we do with each of the iterations, each of the sprints, and how we can infuse the typical unit test and things. A lot more of the testing relies on the development team rather than somebody different or another department. So, and that might be pulling in quality assurance people, or pulling in other people to help in that, but a lot more of it is put on the shoulders of the team that's being worked on. And if it goes unfixed or not taken care of, then that would be back on the product backlog list, and which would then be addressed in the next sprint. Okay, but it's real important to have a working copy at the end of each sprint, and then moving forward. Mm-hmm.
A lot of the panels, a lot of the luminaries in the field upstairs have said over and over again that one of the core processes for security is really embraces individual responsibility. At what point does individual responsibility for the developer get highlighted? The kind of cyber hygiene that keeps getting talked about over and over, but the development process itself says security is a hindrance in development, and it is. They're dynamic with code, but at what point, keying off your last comment there, and full disclosure on the security matter, security can't happen. What you've got, the reward of lack of individual responsibility for security and development is a profusion of insecure code. Worse than it's ever been, and it's trending worse, not trending better.
Yeah, and I think that it really it's going to be a factor that management has to deal with when developing the team, and having the support of management that ensures that there are security types on the team, and the people that are working on the team have been trained properly. Because as programmers, typically we've got 2 days before we need to get something out. So that's not going to be first on our thought process. But having people that is part of it, that's part of this sprint. That is a user story or a feature that has to be met for this sprint to be accomplished. That says easy. That sounds easier than it is, right? But having management back up the development teams and ensure the support is going to be quite critical.
Well, but along that approach, why would security be any different than any other piece of the product? I mean, Scrum Master is responsible for the product. Security is part of the product. It
Right.
doesn't work, but if it isn't secure, it doesn't work.
Correct.
So why would I agree with your skill things. If you don't have the right skills and the right people, that's not gonna. You gotta have that. Just like you gotta have the right coding. But it seems like the best approach would be or the consistent approach would be to make sure that as your chart says, it's in a sprint. It's part of the sprint. It's not in the sprint. It goes on the product backlog. Move on.
Right, but it definitely, that infuse of security, having, not necessarily the security versus developers, but having that planted within the team is going to be so important. And there's different flavors of even Scrum or other Agile developments, how people approach this. But that is one of the biggest things, is making sure that is seen as it's not working code if it doesn't have the security built in.
I have this question. When it comes to security, we're talking just the scope of an application. Isn't there a definable set of vulnerabilities that we would know, that we can say these are the talking points we need to keep on the board? This is what we need to address. This is where we know vulnerabilities happen with applications, either with the way the users are handled, the way the code is executed across the network.
There definitely are some factors to consider, but things are fairly unique, and there's, depending on if you're deploying to the web or if it's within your organization, and there's a lot of different factors, but certainly there are best practices for secure code and things of that nature, areas to look at and to build in. But I don't know if there's really a template as such or prescribed number of items that would be true of any development process.
Okay. One other question that I'm having, and I don't know if it's appropriate to address it now as part of the rest of the lecture, but are there certain languages that lend themselves better to the Scrum process than others?
Well, I think, definitely the object-oriented, Python, Java, there's the newer languages tend to do that just because you can do things in a quicker way, more rapid development way.
What about in terms of products, not necessarily languages, but maybe SAP or some of the other boilerplate products that have been out there?
Yeah, well, one thing in this we have a project each year, and because we want the students to be exposed to programming, deploying to the web, having a web application as far as a standalone part, and we use tools like Python. We use Django for the framework. We use Heroku for them to deploy it. So there are certain tools which we'll actually talk about a little bit later as far as tools that can help us with the security process. Now that's only as good as the people that are using them and what they're using them for, but there are definitely tools out there that can help and that are more conducive to secure code, and some things that are built in, and many features that are built in that maybe people aren't taking advantage of. Okay. Any other questions? Okay. So how to integrate specific security tasks into Agile? Now, there's a lot on these slides, and I'm certainly not going to sit here and read them to you, but just looking back at the sprints, and we know that the features are being outlined in user stories, in the product backlog, and the sprint backlog. So the key is really to infusing those, putting those tests as part of the product backlog, as part of the sprint backlog. Some of the typical tests that we have been used to using, Agile or Waterfall or any of those, must be used and actually required in those various sprints. So that's key. It's kind of a change or a shift of thinking to the way things used to be done, right? So that's a big part. The product manager and product owner, they're typically the ones, he or she are typically the ones that assign tasks. So having somebody work closely with them that is an expert in security, and having the product owner and product manager willing and able and to work with them and to learn from them to infuse the security in these various ways, whether it be on the backlog list, various steps within the sprint, making sure that people are more accountable, not allowing them just to write code without doing unit testing and other testing that is so common. Simple things that we probably did back in programming classes, but maybe not out in the industry because it was all about getting the code done in a certain amount of time. So that's a biggie. And kind of to segue what I was just saying, having having the users realize that that's part of their job. Part of their job is debugging their own code, not just dumping the code to another department or another group to have them test it for them. So changing the mindset of the product owner, the manager, as well as the individual designers, right? Making it seen as a critical part of their job. Also, because we're using Agile doesn't mean that we don't have as many security steps along the way, right? But the good news is that we have many tools that help us do that. Or we'll talk about some of these tools in just a few moments. So the goal is to maintain an agile pace of development, a very quick, kind of iterative approach. Most things in Agile don't really meld well with the traditional types, but with Agile, it doesn't necessarily go with a lot of the older ways of which we develop systems. So we kind of bend security to fit into the process, which is a mind shift, kind of a different way of thinking. Certainly there's going to be trade-offs, and just as Agile, the meaning of Agile means try it a few iterations, see if it works. If it's not working, if we're not getting secure code, we can always change that and adapt that. So kind of having an open mind about this new process is definitely a must in developing code. Now, speaking of, there's tests that go in these various parts, right? We have some pre-sprint tests. This certainly isn't an exhaustive list. This is just a few that I kind of picked out. But pre-sprint tests, daily tests, sprint tests, and so on. So pre-sprint test, right? An analysis before the sprint begins, doing things like threat modeling, right? Looking for design level security problems from the perspective of an attacker, right? So once again, it goes back to the user stories, right? We incorporate the threat modeling into user stories before the task cards are given out, right? So typically in an Agile or Scrum planning meeting, the first thing, people are given index cards. They're given small cards so that they can't write, a page of what the features are. It's one feature per card, and this threat modeling approach is done even before those task cards are doled out, and those are also listed in very succinct ways. Some other security defects list, right? So security defects covers both collecting security defect data and getting the information developers need to address the problems. It can be used in normal testing or other security tests. So security defect backlog should be reviewed each sprint. So some groups will actually have a part of the backlog, but an actual security defect backlog as part of their overall backlog. Some others, patching and configuration management. Most of the time these days we're using open source products as well as writing our own code, as well as other software packages. So having our patches up to date, downloaded, and so on, just building that in as part of the sprint will combat some of the security issues that we can encounter. And then the daily tests, right? So daily, the developers are coding and so on, doing unit testing, right? Probably something that we don't think that much about, but something as simple as unit testing can help just on a daily basis, and making sure that it is documented in some way so that people are more accountable, right? So once again, it's all about including it in the user stories or tasks, and actually checking up on that, right? And like most things, once people get in the habit of doing these various tests in either the daily tests or pre-sprint or sprint tests, it becomes habit after a while. It's met with some resistance in the beginning, but usually there's a bit of training that goes into using Scrum or an Agile process before it's thrown on a development team. Right? Manual code inspection, right? We think of that as being something from way back, as far as having peer reviews or having people look at other code for the sole purpose of not critiquing the programmer, but trying to improve the code, trying to improve the final product. So this also can be done on a daily basis. We can build that in. Now, there's not a set number of things we have to do, but these are just suggestions of things that we can do if we're going to use the Scrum process or Scrum approach.
Can you do a manual code inspection daily?
Depend.
Yeah, because, I mean, how much code can you end up writing then, right? You have the meeting, you go to write the code, you need to make a functional piece each day and have it reviewed before the end of the day, right?
Right. I mean, depending on the size of it, that may be every 2 days. It depends on how you want to set that up. But yeah, if you feel that that's just extra time that could be spent coding, certainly it could be done before, maybe once or twice during the sprint. Also, security regression tests. After each successful build, we could run regression tests. And then every sprint commit test, we could do static analysis test within each sprint. And then there's various tools. We said that there's tools that help us and things that are built in our tools that we might not even be aware of, right? So how can we make this an easier process for our developers, for our designers? So there's tools, things like our IDEs, our integrated development environments, whether you're using Eclipse, NetBeans, PyCharm, whatever IDE you might be using. There's a variety of tools there. Of course, there's the editor, compiler, or interpreter, a debugger. There's other tools. In PyCharm, for example, I run the coverage tool to see not only, do unit tests, but then I see, well, how much code what tests are being covered in my code. So there's these built-in features that can help us in checking our code, testing our code that may or may not be used now. Issue tracker, and that's where do we keep all these user stories that I keep talking about? Well, there's tools. Pivotal Tracker is one of them. That's a biggie. That is a tool that is used for Agile processes, and that's where you put your user stories. That's where you keep track of the user stories. That's where you have your product backlog, you have your sprint backlog. For real large tasks, we might have to break them down, right? So that's a tool, of course, that would help us in doing that. It's a project management tool that assists in keeping the stories, keeping our user stories, subdividing them into what's going to happen in sprint 1, sprint 2, sprint 3, and so on. Then what would we do without version control systems, right? So our version control system helps us manage code that is constantly changing, right? So maybe our team has a GitHub account, and we're pushing our code at the end of each day, and then at an appropriate time, we're merging the code and running the code. So a form of version control system, whether we're using GitHub or others, that certainly we can't really live without those in writing code and having software development projects. Do you guys use Git and GitHub, or do you use other version control tools? Any others that are?
Subversion. I've seen some people use subversion.
Okay, all right. So that's something, that many of our IDEs even have built in. Probably not as well done as a separate version control tool, but certainly we could use those. And then build automation, right, where we convert the text of source code into compiled applications. Most of our applications allow us to do that, and there's a variety of tools built in. And then the continuous integration server, right? This is the next step of the build automation. It connects source code repositories and uses rules to automatically integrate and compile code updates as they're committed. So those can be seen as an actual tool, but whatever series of tools or processes that we're using, right? Think back about using Scrum. We've got the requirements, the tasks, the features in the product backlog. We break them down into tasks by how long we estimate that it's going to take, which sprint we're going to work on them. We also say, okay, we want this much more security driven so that we make sure that our designers are testing their code, documenting it in some way, just to ensure that they're doing it, not taking an enormous amount of time because that defeats the purpose of it. Also having our daily 15-minute meetings to discuss what each member has done. So in those meetings, each member must say what they've done, what problems came up, what they need to continue. So it's not just someone running the meeting of those 15 minutes. Each member has a chance to talk and talk about what they've done and obstacles or things that they need to improve upon that. And then we have the sprints, right? The actual sprint demos where we're demoing to the design team, but more importantly to the customer, the working product, what we've worked on during that sprint. And then we would discuss what's going to be accomplished in the next sprint, what features, what tasks we're going to work on in the next sprint. So regardless of process model, whatever process model we use, right? Because even in some cases, the waterfall approach is not a bad approach if we have requirements that are very set and rarely change. That might be still a model that we use. But most modern day systems and development work calls for kind of constant changes, updates, new features. Customers want to see an end product in a series of steps rather than 4 months, 6 months, 8 months down the road. So I think Agile is definitely here to stay. It's being used by over 65% of development teams are saying that their development projects they're using Agile development techniques. But like all things, it's a change in thinking, right? A change in how we do things. And that's typically met with some resistance, but the end results will help motivate people, right? If we see successful Agile projects, we tend to think, well, that's not such a bad development technique to use. And there's a variety of tools that help us, right? Everything from our just IDE to a lot of these testing tools, and also other ways that we can keep track of things. So, any questions or? Okay.
Got one more that's not directly security related, but plays in with it. In today's environment, where you have these high-order development environments that operate at SharePoint principles, more and more of the projects are sliding towards individual development teams. In other words, it's all-in-one individual development effort by a single person. Is there any kind of offshoot or revision of thinking of the Scrum model
Right, you're not going to stand up with yourself and talk, that sort of thing. That's a good question, and I don't really have an answer to that, to be honest, right now. Most of the, the larger projects are being done in teams, right? So, yeah, that's a good one to ponder, and that might be my talk for next year, right?
Well, there's a big place you see that specifically in government, whereas you've got a SharePoint environment or some other environment. I use SharePoint because it's the most common right now. But they hand the projects out and they say, you develop this dashboard, you develop this process. And whether it's code-based, whether it's out of the box, the overall package is handled to an individual, not a team. There is a team, but it would be too many cooks in the kitchen for more than one person to work on, realistically.
Now, but they're still doing integration of various parts and things, so they're working individually on a certain component, but then at some point in time, or are they doing the entire?
They are doing the entire micro project themselves because there is no greater project. In other words, they have constituencies that all have their individual demands, and they are there to meet all the constituencies' demands rather than a single customer.
Right, okay.
So it turns the model on its head, kind of.
Well, it does to an extent, but isn't this just a way of rethinking how we approach project management? So it's up to the manager to step in and say, okay, we don't have the whole realm of players, but we still have a developer and several users. And those people kind of need to be brought together. And isn't it still possible to deliver
There were,
maybe a core product and then get feedback and then add on change and still have some discussion that's not a complete deviation from the model, the Agile model that you would discuss? It just may not be as inclusive and as wide-reaching.
yeah, I could see that the great need for collaboration between the developer singularly and the customer or the owners, and then probably same iterative approach. But yeah, that's an interesting question. I'm going to do a little research on that and see if that's something that much work has been done on.
So I have a question. So the various IDEs, are there some IDEs that are better at approaching or including security approach and perspective as the code develops, or some better than others, or are some IDEs looking to add or incorporate security in that?
Yeah, well, like Eclipse and PyCharm, NetBeans, those are the ones I'm most familiar with, and they do have the code coverage aspect. There's a lot of libraries and modules that can be used in conjunction with them. And the most popular ones, like the ones mentioned, those tend to, if one has them, then they're quickly going to, have that same feature just to stay competitive. So, yeah, the more well-known ones. I mean, there's some IDEs that are great at just helping you create code and debug it, and that's it. They're very limited, but most of the commercial products are out there that have these different abilities. Yeah.
So if I'm a project manager, and I need some code developed, and I know this, then is it not possible when I write my specification for the developer that he needs to use these IDEs because they have built-in security sets that assist in the security environment?
Things are changing so rapidly, they might want to say a industry-used IDE because, having them use it, but then dictating what features they use, you know what I mean? The features are there if they use it. So I think maybe a better approach would be, rather than dictate the programming language they use necessarily or the IDE they use, is to have an industry use or industry-wide used or commercial product, maybe some suggestions, because things do evolve and companies buy out others. So, okay.
Can I ask a question? You said that the other models, Waterfall and some of the others, are still relevant. Can you elaborate a little bit on what the parameters of the project might look like that would make them more useful in the Agile process?
A lot of real large projects, right? Large projects that have very set requirements at the beginning and they know that they're not going to change or change very little, still go with waterfall or spiral because it's structured. It's a structured approach that's been proven in those arenas. Some people tend to think that agile for large projects, if not managed well, could go a little bit crazy, right? So, that's one thing. Now, as things change and evolve, though, I think that will be maybe turned over to a benefit. But yeah, the larger, more structured requirements that don't change very much, some of those earlier ones would be fine. And a lot of times companies will train their people on what process models they're using.
So because I can see some serious requirements and scope creep, right? When you have a large project and you go into Agile, you start.
Oh, right.
So I could see having a waterfall model for the system perspective, and then break the system into different pieces, and each piece be managed with an Agile process or something.
Yeah, well, that's a good point because these agile approaches, it's not you must do it this way, right? I mean, you can have variations, and most companies do. They'll, depending on their projects, they will use some of the more traditional parts of the traditional processes and use it in a more agile way. Because yes, that's one of the possible drawbacks is the feature creep, the users kind of demanding. I mean, when do you stop? How many sprints are you going to have? So that's something that I've seen. Some companies just say, okay, we're using Agile because we want that quick development time and we want to collaborate with users and product owners, but we have to have a kind of a harness on it. We can't, let it go kind of completely wild. But it really has made, I think, great strides or great improvements in software. And software is relatively a new field, right? Software development, as compared to other engineering fields, right? Software engineering hasn't been around that long, so we're still kind of trying out different techniques, different ways of doing things, and it doesn't help that the software and the technology and the demands change very quickly, so we're always kind of looking at different ways to make it better, to get the product on time, under budget, and what the customer wants, right? That's what we strive to do. And these various process models are just an approach, right? But we certainly, depending on our company, our team, we could vary it from many, many different ways. Okay. Well, thanks so much for coming. I appreciate the hardcores that stay till the bitter end. I really appreciate it.
Hardcore's always at the end of any presentation.
All right, well, have a great day, and I will see you later, okay?